Hi, Assalamualaikum everyone. So today we proceed to the next subtopic for chapter 12, thermal expansion. So there are two learning outcomes here. First, you should be able to define coefficient of linear, area and volume thermal expansion. Next one, you should be able to solve problems related to thermal expansion of linear, area and volume. Okay, first let's look at what is thermal expansion. Okay, in simple words, it is a change of a body size in response of a change in temperature. So when there is a change in temperature, the solid, the liquid and the gas can change in terms of three types, which is first linear, second area, last one volume. Okay, so let's look at first one, linear expansion. So when the temperature change, the length will also change. So linear expansion dekat sini maksudnya perubahan dari segi length. So initially the length of the solid may be 10 meter, and then when there is a change in temperature, maksudnya solid ni dipanaskan, the solid will expand by maybe 0.5 meter. So this change in length, we call it as delta L. And L is the final length of the solid. So here we have a terms we call as coefficient of linear expansion, ataupun kita gunakan alpha, where it is defined as the fractional change in length per degree change in temperature. Or we can write it down in terms of this formula, di mana alpha adalah sama dengan delta L bahagi L0. L0 adalah initial length darab dengan delta T. Dan unit untuk alpha adalah per degree Celsius ataupun per Kelvin. Okay, so daripada formula ni, kita boleh rearrange and then dapatkan this equation. Because usually soalan akan minta what is the value for delta L or L0 or delta T. Usually dia akan minta that one lah, dia tidak akan minta kita cari untuk value for alpha. So basically the coefficient here just to indicate that when the alpha of a certain solid increase or higher, it will expand faster. So it will expand faster. Okay, so the delta L here, since delta L ni adalah the value, the length of which it expand. Maksudnya daripada sini ke sini ni adalah delta L. So delta L ni adalah sama dengan L minus L0, final length minus initial length. Dan delta T juga adalah final temperature minus initial temperature. Dan final temperature here is the higher temperature. This one adalah the lower temperature. Dia tidak sama macam dekat 12.1. 12.1 final temperature adalah lower because heat flows from higher temperature to lower temperature, right? Okay, tetapi dalam expansion, sebab bila kita increasekan temperature, obviously dia akan expand. So final temperature will be higher than the initial temperature. And when we substitute this one into here, kita akan dapat this equation. So L is equal to L0 1 plus alpha delta T. So we either use this equation or this equation, depends kepada soalan. Okay, next one is area expansion. So daripada nama kita tahulah, it is the expansion of the area of the solid. So here we use coefficient of area expansion, which is beta. So beta adalah sama dengan delta A divided by A0 delta T. So pattern dia sama juga macam alpha, but now kita ubah in terms of area. And unit pun sama. And the equation here is delta A is equal to beta A0 delta T. It's the same thing, di mana delta A adalah change in area, final area minus initial area. And then apabila kita rearrange the equation, we will get this equation. So here, if we want to relate between alpha and beta, so akan ada certain soalan dia bagi in terms of area expansion, tetapi value yang dibagi adalah alpha. So we can find that the beta of the solid is equal to 2 alpha. So this one nanti kita akan tengoklah dekat dalam example nanti. Okay, and then last one is a volume expansion. So meaning that here the change in volume. So this one salah, ada typo, so kamu ubah kepada volume. So the coefficient of the volume expansion we use gamma, di mana gamma adalah sama dengan delta V divided by V naught delta T. As you can see here, it's the same pattern. Kamu just ubah kepada volume. And then volume, delta V is equal to gamma V naught delta T. And then rearrange, you will get this one. It's all the same pattern as you can see here. And the relationship between gamma and alpha is gamma is equal to 3 alpha. Okay, so here you need to take note that linear expansion for solid, linear area and volume expansion happens in solid. But for volume and gas, for liquid and gas, okay, volume expansion only happens in liquid and gas. Okay, so ada dekat sini dalam nota. In liquid and gas, only volume expansion occurs. In solid or linear area and volume. Okay. Let's look at the expansion of liquid in a container. Okay, so when liquid is inside the container and they are heated at a certain temperature, both liquid and the container will expand. Okay, bukan liquid saja yang akan expand. Container sekali akan expand because container is a solid. But the liquid will expand faster than the solid. So that's why apabila kita panaskan liquid akan and then at a certain temperature it will overflow. So here, if the question asks in terms of density, since volume adalah sama dengan this one, volume adalah sama dengan mass divided by density of the liquid, so kita boleh substitute this one and then akan dapat another new equation which is in terms of density. Okay, so kita akan tengok example in the next video. That's all for this subtopic.